So how was the spring break, guys? How was it?
It's clear.
The spring break was great.
It was great.
Okay.
No weather.
So yeah, I realized that because you guys just returned from spring break, so that's why I didn't take chapter 13 in midterm 2. But I will give a extra credit quiz for chapter 13. Okay.
Okay.
And I will open that on the same day the exam starts, but it will be due on April 5th, the extra credit quiz. But the exam is due from March 29th to March 30th. Okay. So yeah, just 2 chapters in midterm 2, and this time I have made it really easy. Only 33 multiple choice questions. So last
May I ask how many questions are it?
total 33 MCQ questions.
23?
33.
Thank you.
Yeah, let me write it. Let's write it in the chat. So you guys saw midterm 2. Only 33 MCQ questions, and chapter 11 and chapter 12. Okay, this time it will be very easy, and we will do some worked out problems as well today's review.
Thank you.
Okay, so first of all, we need to know what's covered in chapter 11, right? So chapter 11, you guys should know the symbols, the notation, like what this sigma stands for. It stands for what? Standard deviation. And sigma square stands for what? Variance. So these are should be pretty easy because most of you guys have already seen my lectures, I believe. So what sigma stands for, what sigma square stands for, or what S stands for, right? It's standard deviation of sample. So always be careful between sample and population. Okay, if I'm asking for sample, you know I'm asking for S. Or if I ask variance of sample, then S square. Okay, is that clear?
Yes.
So this shouldn't be too hard. So it's pretty straightforward in that sense. So we have covered it in our class, right? So also need to know the notation, what chi-square stands for, or for lower tail we write LT, upper tail UT, so on and so forth. All right. So again, you need to know when is it upper tail. When our chi-square test statistic is greater than degree of freedom, it's in the upper tail. If our chi-square test statistics is lower than degree of freedom, it's in the lower tail. Okay, and you need to know maybe the properties of chi-square distribution. So we did lot of examples in class, and we have covered it in our lectures, so you guys are aware of this as well. Okay, upper tail and lower tail chi-square value and how to use the chi-square table. Okay, so the most important thing, this question will be in the midterm 2 exam. Okay, hypothesis test about a single population variance. First you need to identify whether it's in the lower tail test or an upper tail test, or is it a two tail test. So how do you know if it is upper tail or lower tail? So these are the properties, right? So if population variance is less than a given number, it's a lower tail test. If population variance is greater than a given number, it's in the upper tail test. And if it is different from a given number, it's a two tail test. Okay, And the most important formula which should be in your cheat sheet is this formula. Okay, so I will do a example right now so you guys know how to solve it in the exam. Okay, so this should be in your formula sheet. Okay, and degrees of freedom n minus 1. Okay, so let's do a problem. So it will we have covered it in our lectures, but doing a problem will refresh your memories. Okay, so let's use a different color. Okay, let's do this problem. So a cranberry juice manufacturing company has designed its bottle filling process with a variance of 0.0225. So this is the variance, right? So variance is denoted by, what do we denote the variance by? Sigma square, right? So it conducts regular quality control test to see whether the process is running according to the design specification. To the end, a quality control analyst takes a random sample of 25 bottles. So sample is denoted by what? N, right? Number of samples, N. So N equals to 25, sigma square is 0.225. So cranberry juice, and finds a sample that has a variance of 0.004. So this is what variance? This is sample variance. So sample variance denoted by S, right? If we go back to our lecture, so sample variance is denoted by S square. So sample variance, this is S square, is 0.004. Okay, so the population of bottle content is assumed to be normal, so it's a normally distributed. So conduct and interpret a hypothesis test at alpha significance 0.05 to determine whether the population of variance of the bottle is different from 0.225. So it says different from. So is it a lower tail, upper tail, or two tail? Anyone in the class? Two tail, good. So you guys have watched the lectures. So if it is a two tail, how do I set up the hypothesis test? So let me, so hypothesis test, if we, so let's write it down first. So sigma square 0.0225, S square is 0.04, n given is 25. So step 1, set the hypothesis, which is sigma square is equal to 0.225, right? 225. So what would be the alternative hypothesis, HA? It will be not equal to 0.0225. So how do I know it's a two tail? Because it says different from, right? So if we go back to our formula sheet, so it is different from a given number. And now step 2 is calculate the test statistic. So we use this formula. Let me use a snapshot tool. Okay, copy this formula there. Okay, it's a little small, but it's okay. So n minus 1 s square divided by, this is step 1, and step 2 is calculate the test statistic. What's this? Okay, so n minus 1, so 25 minus 1, and then s square is 0.004. Actually, let me write the formula properly. Okay, it's too small. So n minus 1 s square sigma square. This is the chi-square test statistic. Okay. So 25 minus 1 s square is 0.04, and n the hypothesized sigma square is what? 0.0225. So we get if you use your calculator, we will get 42.667. Okay, so we completed step 2 as well. Is that clear? What's the third step? Decision making rule. So do we reject or not reject? So if we look at our formula, why this is okay. So decision making rule, we can use two-tail approach. We can use the critical value approach or p-value approach. But in the exam, we will use critical value approach, because for p-value we need to use calculator, right? Excel. But so let's use critical value approach. So what's our significance level? 0.05. So since it is two-tail, we have to divide it by 2. So 0.025. Okay. So 0.025. So there will be two critical tails. So let's open the chi-square table. Oops. So two tails, right? So lower tail, critical value of chi-square 0.025, because you have divided by 2. Lower tail. So what's the lower tail critical value using our chi-square table? So lower tail is on the top side, and upper tail is on the bottom column. So let's first find the 0.25. And what's the degree of freedom? In this case, what would be the degree of freedom? How many sample was there? N. So for degree of freedom, what's the formula?
-1.
N minus 1. Brilliant. So degree of freedom is 25 minus 1, which is 24. So 0.025, 24. So the lower tail critical value, first let's find the lower tail critical value. It's here, right? 0.025. Lower tail always in the upper row. So that is 12.401. What about the upper tail critical value? 0.025 upper tail. Upper tail is on the lower row, right? Lower row 0.225, and degree of freedom is 24. It's 24, right? 39.364. So we can use you can draw the critical value diagram, right? So this is the lower tail critical value 12.401. Upper tail critical value is 39.364. And what is our test statistic? 42.67. So let's use a different color. Okay, use a different color. So our value is here 42.667, right? So we know that this is the rejection area, right? And this is the rejection area. So do we reject or not? What do you guys think? Does it fall in the rejection area?
Yes.
Yes. So because our chi-square test statistic is greater than chi-square of this is actually in the upper tail, right? So 0.025 upper tail, because 42.667 is greater than 39.364. So we reject H naught. That means except HA. Okay. So that means if we reject H naught, what would be the interpretation? That means the variance is not equal to 0.225. Okay. So alternative is true. So interpretation, alternative is true means sigma square is not equal to 0.0225. So we can say at alpha 0.05 significance level, the population variance is not 0.0225. Okay, so this type of question will be in our midterm 2. Okay, so we did a problem here and pretty straightforward. Okay, so next one, so you guys know this condition, when to reject, when not to reject. For a two-tailed test, for critical value approach, these are the conditions that need to be fulfilled. So write the conditions in your cheat sheet. Okay, you have a 2-page cheat sheet, right? I mean both side. It's a single page, double-sided. Is it clear?
Yeah. Yes.
Okay, good. I did an example and I showed how to use the formula as well. Okay, already I did it in the lectures, but just a recap. And you actually can find it here as well. So I will definitely ask that one, the single population variance question. There will be a similar problem, not exactly the same problem. Then you need to know what is a F distribution. You need to know their properties. Okay, so write it down in your cheat sheet. And for F distribution, you guys know that they have 2 degrees of freedom, numerator degree of freedom and denominator degree of freedom, right? And it is always positive. So these are the properties. So let's look at another example. So I have given another question about 2 population variance. So this is the one that we have to use F test. Okay, so previously we used chi-square distribution, but for this purpose we have to use the F test, and the formula is given here. Okay, this should be in your cheat sheet as well. And how many degrees of freedom do F test have? They have 2 types, right? One is the numerator degrees of freedom, another one is the denominator degrees of freedom. So let's do a problem based on that. So this was the chi-square problem. Always read the question, okay? So here they are saying a transport company would like to prove that they have lower variability in delivery times than the competitor. So an analyst at the company obtains two random samples, sample of 41, which should be okay, and with a variance of 256. Okay, and a random sample of 61, which is the other one, with a variance of 4.15. Delivery times for both companies are normally distributed. So we have N1, N2, we have sigma 1, sigma 2, right? And I always said that the larger variance should be sigma 1, right? So if the larger variance is sigma 1, okay, sigma, actually larger variance, this is for what? This is for a sample, right? Let's see, for a sample. So it should be S1 square. So if the larger variance is S1 square, the smaller one would be S2 square, right? Then the smaller one sample would be N2, and the larger one the larger one is N1, larger one's variance, and this one should be N2. So let's actually write it down properly here. So N1 is 61, S1 square equals to the larger variance 4.14, N2 is 41, S2 square is the smaller variance 2.56. Okay, don't get confused here. Okay, Manav, yeah, you have a question.
Why do we choose the larger variance for sample variance 1 instead of just like the first order it comes in?
Yeah, it's a very good question. So if you have watched my lectures, because F distribution is always upper tail test, and for upper tail test we have to make the bigger variance in the numerator. That's why the bigger variance is always S1.
That makes sense. Thank you.
Okay, clear? It's good. You ask the question, it helps the other students too. Okay, so let's read the question. So they said, conduct and interpret a hypothesis test to determine whether we have a lower population variance than our competitor. Okay, so lower than our competitor. So here 4.15 is greater than 2.56, right? And our competitor is actually so if we have a lower population variance than our competitor, so our competitor is actually this one, right? And we are actually this one, the S2. So if they we have a lower means they have a greater than us. So the alternative hypothesis would be the competitor is bigger than us. Make sense? Because competitor is population 1, we are population 2. So if we have a lower population variance, that means they are bigger than us. So that's the alternative hypothesis. So, and the null hypothesis would be the opposite with an equal to sign. Okay. So now if we do, so this is how you set up the hypothesis test. Okay, this is the setup. So test statistic is simply S1 square over S2 square. If we go back to our formulas, right? S1 over S2. So that would be 4. Their variance is 4.15, and what is our 2.56? Okay, this is our one. Let me use the calculator. So the F test statistic would be what? 1.62. Okay, and third step is we have to make the decision making rule, whether to reject the null hypothesis or not, and the significance level is 0.01. It was given in the question, right? So before we do that, we need to find the degree of freedom 1 and degree of freedom 2. What's the degree of freedom 1? N1 minus 1, right? N1 minus 1. And degree of freedom 2 is N2 minus 1. This formula should be in your formula sheet. So degree of freedom 1, N1 is 61 minus 1, so 60. Degree of freedom 2 is 41 minus 1, which is 40. Got it? So we have 2 degrees of freedom. So first one is the numerator degrees of freedom. This is the denominator degree of freedom. So we will use critical value approach because in the exam we won't have Excel to calculate p-value, right? So we have to use F table. So F table is here. We have 2 degrees of freedom. So 60 is the numerator, 40 is the denominator. So 60 numerator 60 is here. 40 we have to move to maybe yeah, this page. Oh. So 60 and 40, and the significance is 0.01. So numerator is so let me highlight 60. Denominator is 40, right? And it should be 0.01. So this is if we go back here, where it cuts at, can you guys tell me where the 60 and 40 cuts with 0.01 significance level? Manav?
2.02.
Okay, so we got the critical value 2.02. So upper tail critical value, because F test is always upper tail, at F 0.01 equals to 2.02. So if we draw the F distribution curve, critical value is 2.02. And what was our test statistic? 1.62, right? So use a different color. So 1.62 is where? Here. But the rejection area is this area. This area is the rejection area. So do we reject?
No.
No, because is less than the critical value. So do not reject H0. That means if we do not reject, HA is unsupported. So if it is that that's the case, then we cannot say that our variance is less than them. So we cannot say that because HA is unsupported. So that's the interpretation. So I will give a similar question in the exam, and only 33 multiple choice in midterm 2. Okay, so it's very easy. So that's chapter 11. Is it clear to every one of you guys? And
Yes, when you do it.
Yep.
Yeah.
and always write down the conditions. Yeah, when I do it, it's okay. You should practice the worksheets. Okay, I have uploaded all the worksheets video. If you see, do worksheet 6 and worksheet 7.
Okay.
Okay, it's in modules. I think Adrian, you don't have the worksheet videos, right?
Yes.
Because you are in my incomplete grade student, so you will find it in my YouTube channel, or I can send it to you.
Okay.
Okay, so there's a video worksheet 6, worksheet 7.
Yeah.
Okay, so that's chapter 11. Pretty much very easy. So I intentionally went over these problems because I did it in class. Anyway, I did that in class, but it's good to recap. Okay, so for chapter 12, you need to know what multinomial probability distribution are. Okay, so what's an expected frequency? You write down the formulas. It's easy. I mean, uh, pretty straightforward. I did a lot of examples in class, and I will give a question on goodness of fit test for a single categorical variable. Okay, I will do a word example as well, so don't worry. And these are the formulas which should be in your cheat sheet. Okay, make sure you write all these. I have highlighted them in red. You should write them like what they are. Okay, in your cheat sheet they should be there. Okay, let's do actually that problem. I think I did it in class, but I didn't give in the slide. Let's do that problem. So bike shop sells bikes with frames made from 4 different materials. So this is actually the goodness of fit test. Okay, so this is from chapter 12, goodness of fit test for single categorical variable. So a bike shop sells bikes with frames made from 4 different materials: carbon fiber, aluminum, steel, and titanium. So in the past, shares of sale by type of frame was 17% carbon fiber. So carbon fiber was 17%. So let's write it down. Maybe frame. Let me use a different color. These are frames. This is the percentages, and then the probability you have to write, right? So the first frame is what? Carbon fiber. So carbon fiber was 17%. And I told you guys that percentages you have to convert it to probabilities. So how do you do that? You divide by 100. So that's 0.17. So carbon fiber is 17%. This is in the past. Aluminium is 53%. So 53 by 100, 0.53. What about steel? Steel is 12%, right? 12 by 100, right? Steel 12. And then titanium is 18%. So number 4 is the titanium. So titanium is 18%. So 18 by 100, which will be 0.18. Okay. So yeah, it was in the past. So the bike shop want to use a goodness of fit test at the alpha equals to 0.5 significance level to see whether the probability of sales by frame has changed from the past. So if it changed from the past, so how do you set up the goodness of fit test? So first you write probability distribution, this and this. So null is the probability distribution of frame type. Here this is frame, right? Distribution of frame. So this can be P1, this is your P2, right? The fraction, this is P3, this is P4. These are all probabilities, right? So the probability distribution of frame, you say that P1 was 0.17, P2 0.53, P3 was what? Probability was 0.12, and P4 is 0.18. Okay, I have to move it a little here. Okay, this is your hypothesis. And the alternative would be the probability distribution of these frames is not P1 equals to 0.17, P2 equals to 0.53, P3 equals to 0.12, P4 equals to 0.18. Okay, so the not has to be before this statement. Many students by mistake they think that I should just make not like this. No, this not doesn't mean the same thing. Okay, this will be a mistake if you write it like this. Okay, in the MCQ you might get confused, but the not should be here. Okay, is it clear? So if we can reject the null hypothesis, then we can say that yeah, it has changed over the years. So let's see in reality what is it like. So hypothesized probability, we need to fill in the first one is 0.17, it was given in the question, 0.53 P2, right? P3 0.12, P4 was 0.18. But in reality, what's the observed frequency? 66, 128, 16 and 14, right? So it's 66, 128, 16, and what's the other one?
40.
40, yes. Other one was 40. So what should be the expected frequency based on the total sample? How many samples are here? 66, 128, 16, 40. If you sum, total is 250, right? Total n. So if the hypothesis probability hold true,
Something's not right.
what's not right?
Oh, sorry, it was my Siri. Sorry.
Yeah. So if you want to find the expected probability, what's the formula for the expected probability? Manav or anyone?
Observed minus
No,
the
it's
expected
n.
frequency.
It's n times p1, right? So what should be e1? N, the total number of sample size times the probability of 1. So total sample was 250 and the probability should be 0.17, right? If you use your calculator, let me use a different color. What should be the expected probability? 25 times 17.
42.5.
Yes, 42.5. So this is the what I should expect. But I observed 66. What should be E2? N times P2, right? N is 250 times P2 is 0.53. That would give us to be 132.5. Then E3, N times P3, right? I'm just doing it directly because I actually have the numbers in front of me. So it should be 30. And E4 should be N times P4. that would be, I'm directly writing it, okay? You guys get the picture. 45. Now you have to find f minus e whole square divided by ei. So if you do for all of them, so first one is f1 minus e1 by e1, and this is square, right? Let's move it a little here, okay, easier to write. So observed is 66 minus 42.5 square divided by 42.5. You will get, let me use a black color, you will get 12 point, let me reduce the font a little, okay, 12.9941. So 12.9941. Then you do for all of them. So f2 minus e2 square by e2. So f2 is this one, 128 minus 132.5, right, square. So in the exam, always keep 10 blank pages with you because you need to do some rough work, okay? 132.5. So that would be what? 0.1528. So 0.1528. Then f3 minus e3, which is 16 minus 13 divided by e3, and this is square. So 16 minus 30 square divided by 30, that would give us 6.5333. Always keep it in 4 decimal places. And last one, f4 minus e4 square by e4, which is what? 40, right? 40 minus 45 square divided by e4. So e4 is 45, right? So divided by 45. So that would give us, if I write it down here, it will be 0.5556. So 0.5556. So then you sum all the chi-square, you add them up, that will give your chi-square test statistic. So 20.236. So in the midterm, I might give a table and I might blank out this part, right? Or I might blank out the expected frequency of this part, right? So you guys can calculate them, right? You know that this is E2. So E2 is N2 times P2, right? If I ask you find the difference square expected frequency, this part, you know I'm talking about this part, right? Is it clear how the MCQ question will look like? So don't get don't get confused. I will blank out. I will give you the table but incomplete. Like some of them will be missing, and it's easily you can find it out. Okay. So we got the test statistic very good, and now we have to make the decision making rule. So decision making rule, what is the degree? First we have to calculate the degree of freedom. So we can only use critical value approach, right? Reject H naught or not. So because p value you will not have Excel in the exam, so you can only use critical value approach. So first, degree of freedom for goodness of fit test. What is the degree of freedom for goodness of fit test? It is k minus 1. What is k? K is the number of category. It's not sample size, okay? So don't get confused and do n minus 1. Here it's k minus 1. So how many categories are there, Adrian?
It's 4.
So 4 categories.
No, it's 1 category.
No, there are 4 categories here.
Oh, okay. Yeah.
So if I do 4 minus 1, so degree of freedom would be 4 minus 1 should be 3. Okay. So don't make this mistake. In the goodness of fit test, many students by mistake do n minus 1. It's not n minus 1. n minus 1 will give you a wrong answer. So 3. And what is the significance level in this case for the upper tail test? 0.05, right? It's given in the question.
Yep.
Okay, so 0.05 and 3. So what is the critical value in this case? You have to go to the F table. Okay, don't look at the chi-square table. In the here you have actually sorry, here you have to look at the chi-square table because it's a goodness of fit test. I'm sorry about that. Okay, it's the chi-square. Yeah, it's a chi-square test. It's written chi-square. So chi-square. Will it be an upper tail or lower tail?
Upper tail.
Why? Why will it be an upper tail? There is a condition, right? If the chi-square test statistic is greater than degree of freedom, it should be in the upper tail. What is our chi-square test statistic? 20.236.
20.236.
Is it greater than degree of freedom? Does it meet the condition? Yes. So it should be an upper tail test. Clear? You have to know why it is upper tail. Don't just blindly find the upper tail, because in the chi-square test statistic we have two tails. The lower tail is in the topmost row, and upper tail is the bottommost row. So 0.05, let's use a different color. 0.05 in the upper tail. Upper tail is always in the lower row. Okay, lower row, upper tail. So 0.05 and the degree of freedom is 3. So yes, 7.815. So this is making more sense, right? So it is an upper tail critical value because it met this condition. Our chi-square value is greater than degree of freedom. So chi-square 0.05 upper tail, that is 7.815. So let's draw the diagram for the critical value. And so upper tail is here, 7.815. And what is our test statistic? 20. Let's use a different color. Okay, 20 should be somewhere. Why is it coming?
236.
Yes, 20.236. So this falls in the rejection region, right? So we reject the H naught. So reject H naught. If we reject H naught, that means HA is accepted. Why we reject H naught? Because our our test statistic to 20.236 is greater than the critical value, which is 7.815. It is greater, so that's why we reject H naught, and HA is accepted. That means the proportion has indeed changed over the years, because the alternative, I wrote H, this should be alternative. That means the probability is not same anymore, so it has changed over the years. Is it clear to everyone? Manav, any questions?
No questions. It's clear.
Oh, Ankit has been waiting for a long time. Manav, Mohammed, okay. So yeah, only 33 MCQ questions in the exam. So goodness of fit will definitely pop up. Okay, don't get surprised, and don't make the degree of freedom n-1. It should be k-1 for goodness of fit test. I have intentionally made it very easy so that you guys can relax a little. Okay. The last part, there is one more part, I think. There were like 4 typical questions. the last portion for chapter 12 is the where is it? Why is it switching back and forth? My mouse. Okay, so test for independence for two categorical variables. Okay, this problem also I did it in class. This is a little complicated. Why is it? Yeah, this problem we did it in class, the test for independence. So this is the formula which should be in your cheat sheet, the coffee example that I did in class. And here the degree of freedom is a little bit different. Okay, so let's highlight this part too. Anyway, it's not getting highlighted, but it's okay. We will do the problem of this, the test for independence using their formulas. And so let's do the coffee example. So an analyst of a coffee chain of coffee shops suspect that customer drink choice is related to the time of the day when the customer comes in. Okay, three drink choice the analyst would like to consider are hot coffee, iced coffee, specialty drinks. So there's three drink choice. An analyst takes a random samples of 503 customers and then split the customer into two groups. So one is before 11 a.m. and the other is after 11 a.m. So of the customers who came in before 11 a.m., 90 ordered hot coffee, 79 ordered iced coffee, and 72 ordered specialty drink. Okay, so let's write down those information: 90, 79, and 72. So if we write it down, 90 people hot coffee, then 79 ordered iced coffee, and then specialty drink 72. Okay, that's before 11 a.m. Okay, so that's one part. Then after before 11 and 90 ordered. Okay, and who came in after 11 a.m.? 67 hot coffee, 74 iced coffee, and 121 specialty drink. Okay, so after 11 a.m., 67 ordered hot coffee, 74 iced coffee, and then 121 specialty drink. So this is the contingency table. Okay, so this is the contingency table that we have. In fact, we can write down the observed frequencies because we already have this information, like 90 okay, before 11 a.m., right? After is 67, right? Let's check. 90 before 11 a.m., 67 after 11 a.m. Okay, so 90, 67, then the next one is 79 before 11, 74 after 11. So 79 iced coffee is before and after is 74. What about the other one? 72 and 121 specialty drink. So specialty drink before 11 is 72 people ordered and after 121. Okay, so why did we do this? Because we first, these are the observed, but to calculate the expected frequency, okay, let's look at our expected frequency formula. So expected frequencies, we have to use the row total column total formula. So let's write it down here. There should be here in the sample. Row total times column total divided by the number of n. So this formula also should be in your formula sheet. Okay. So to find the row total, we first have to sum in the rows. So 90 plus 67, what is the row total here?
164.
No, row total.
I got 157.
157. Okay. What's the row total for this one? 17 and 74.
153.
153. Specialty drink is 72, 121. If you add them.
193.
193.
Okay. And what's the column total?
41. 41.
90, 17 and 72. Is it 241? Okay. And what is the column total for this column? 67, 7.
62.
262.
262. Okay. So we know the row total and column total. So what would be the expected frequency for hot coffee before 11? So that is row total. The formula is row total, right, times the column total divided by total number of n in the sample. So what's the total n in the sample? 241 plus 262, or if you sum the row total, it will give you the same number, 503, right? So what is the expected frequency for hot coffee before 11 am? What's the row total for this one?
Would be 157.
Okay, and what is the column total for this combination?
241.
241, right?
And then total n is over 503.
Yes. So this would be our expected frequency of hot coffee before 11 am. So H 11 am before, okay? So that is what it comes out.
28.0915.
What was it? 90 times
79.
75.22.
75.22.
Yeah, mine's wrong. Sorry about that.
Okay. So you got it, like how we should solve it, right? 75.22. So if we look at our, actually I have done this here. I actually did only one part here, okay? So in the midterm, okay, some of the parts will be filled and some won't be filled for you. So you have to solve it yourself. And similarly, then once you find it, let's do one of these, like F11 minus E11 over E11 square. Right? Let's do this part first. This is nothing, 90 minus 75.22 square divided by 75.22. What is that value? 14 square, 220.
2.9.
Yes, 2.9. Always keep it in 4 decimal places, okay?
Okay, 2.904.
Yeah.
1.
So something like that. So once you fill up all of them, you fill up this, 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 you will be able to derive the chi-square test statistic value. All right. So once you do that, here that another thing you have to be careful of is the degree of freedom. So what's the degree of freedom in this case? R1 minus 1, C1 minus 1. What's R1? R1 is the category 1. So how many categories are here in this case? 1, 2, 3. 3 categories, right? 3 categories for variable 1, 2 categories for variable 2. So R is basically categories in variable 1 and C means categories in variable 2. So we have how many categories in the first category table? Hot coffee, iced coffee, specialty drink. So what is the value of R? R equals to 3. What is the value of the second category? That is C. It's only 2. Before 11 am and after 11 am. 2. So what would be the degree of freedom in this case? 3 minus 1. 2 minus 1. So this would be 2 times 1, which is 2. So you got the degree of freedom, and let's say the chi-square value is 20, just for assumption, okay? Because I'm not doing the entire problem because it will take a long time. We did it in class. Okay, watch the lectures of the hot coffee example. So then you use the chi-square table just like how we did previously. And if your chi-square value is greater than degree of freedom, it's an upper tail test. So if it's an upper tail test, upper tail is always in the lower row. Okay, and with the significance level, you can find the critical value and then you compare it with your test statistic. Okay, then you can reject or you can you fail to reject. Is it clear for all of you guys?
Yes.
Yes.
Can you go over that last part again with the table, please?
Oh, the table. Okay. So let's say hypothetically, okay, let's say the chi-square value is 20, right? So
Yes.
if our chi-square value is greater than the degree of freedom, then it should be what? It should be what? If it's greater than degree of freedom, upper tail, right? So if let's say our chi-square value is 20, it is greater than degree of freedom. Degree of freedom, let's say is 2. Then of course it's in the upper tail, right?
Yes.
Actually, just give me a minute. I have the solution for this. In the class we did it. So let's open the problem here. Okay. So let me just copy this one using a snapshot. Okay. So what is our chi-square value? 15.123, right?
Yes.
This is greater than 2. Agreed?
Yes.
So if it is greater than 2,
Yes.
then it should be in the what? Upper tail or lower tail?
Upper tail.
Upper tail. Because if this condition is fulfilled, let me use a black color. This has been fulfilled, so it should be in the upper tail. So let's look at the upper tail value. Okay, so upper tail chi-square value. What is the significance level in the question? 0.01. Okay, 0.01. So 0.01. Upper tail is in the lower row, right? Agreed?
Yes. Yes.
So let me use a purple color, different color, okay? And what is the degree of freedom for us? 2.
2.
What is the critical value?
9.210.
Right. So our chi-square critical value is, so critical value approach, chi-square 0.01, upper tail, critical value is 9.2210. Yeah, 10. So if you draw the diagram, so upper tail 9.210. And what is our test statistic? our test statistic value is 15.123, right? So this should be here. Let's use a different color. It falls in the rejection region, right?
Yes.
That means reject. Yeah, and then if you reject H naught, HA is accepted. Is it clear now?
Yeah.
Okay, so accepted means that that they are independent of. So if you go back to the test for independence in our review, so if you reject H naught, then at alpha significance level, we can conclude that variable 1 is not independent of variable 2. That means variable 1 and variable 2 are related. So if we reject H naught, that means they are related to each other. So you can say that the type of coffee is related to the timing of the like drink choice is related to the time of visit, right? So these conditions should be in your cheat sheet as well. Where is it? If you reject the test for independence, what does it mean? Okay, so that means yeah, type of coffee is related to the time of visit. So I can give a similar question. I can give like different types of sports, and I can say different time of instead of 11 a.m. 9 a.m. I can give the timing of sports like morning or night, something like that, and ask you guys to find the intermediate values of this. All right, so that's about it. That's midterm 2 review. I cannot disclose too much like the exact question, but before finishing it off, I will also want to give you guys some practice problems of the Excel, because many of you guys have complained that oh, we don't have Excel, Professor, how to solve this type of problems. So I gave a chi-square example and an F-test example. So let's try to see which one it is. Consider a lower tail test at alpha 0.1 significance level with chi-square test statistics of 136 and degree of freedom 180. So to calculate the p-value, what function should we use in Excel for a chi-square? So it is a lower tail test, right? So chi-square lower tail test already, and the significance level is 0.10. And degree of freedom is given, test statistics is given. So which of the options will be valid? Let's look at the formula sheet. Which one? Let's look at the formula sheet, all right? So the chi-square and the for the chi-square, if it's a lower tail test, no, this is F statistic. If chi-square is lower tail test, we use chi-square dot dist. First we put the test statistic, then we put the degree of freedom, then we put the true. So let's see. So test statistics, degree of freedom, and true. So it should be C. Okay. So you don't need Excel to solve in the midterm. Basically, I asked which formula should I use, because I want to see whether you know which one we should use, right? So that's for chi-square example. So these things should be in your formula sheet. For a upper tail test, this should be in the formula sheet. This is for lower tail test, and for upper tail test, this is the one. Upper tail test chi-square, we don't need to put true. Okay. Okay, let's do an example for F-test example. Consider a two-tailed test at alpha 0.1 significance level with F statistic of 2.30, numerator degree of freedom 45, denominator 41. What Excel function should we use? And this is a two-tailed test. So two-tailed means always it has to be multiplied by 2, right? So B is automatically cancelled because it doesn't have multiplied by 2. So I eliminate one chance already. Now I know degree of freedom for first one, df1 is 45, df2 is 41. So 45 A is cancelled because the first one is 41, 45, it doesn't follow the order. Even D is cancelled because df1 is 45. So the only valid one remains is C. Okay, and if you want to verify, you can go to the formula sheet for F test. For a two-tailed test, this is the formula sheet. Is it clear, guys?
Yes, it
That
is.
one was C.
Yes, it is.
Okay, so see, I didn't trick too much. This exam, I think one of the easiest in my 7 years. I have given numerous exams, but this exam I made it so easy. You should literally ace it. If you have gone through the review notes, do the worksheets, and those of you who watched my lecture 11 and lecture like chapter 11 and chapter 12 lectures should be a piece of cake. Okay, and I literally covered all the examples in the class, and you don't need an Excel to do the problem in the class. Okay, so thank you. Any last question? I wish all of you like a good luck. And chapter 13 extra credit, I will give maybe 12 multiple choice questions. You have to submit by April 5th, so you have at least 2 weeks from today if you count. So chapter 13, do it later. Focus on chapter 11 and 12. Try to ace the midterm 2. Okay,
Thank you, Professor.
you are welcome,
Thank you
guys.
so much.
You're welcome. And one last question, Adrian.
Yes.
You can find the worksheet in my YouTube channel. Okay,
Okay.
I will send you all the PDF files, like these PDF files. You can visualize and see.
I do have those.
Oh, you do? Okay, that's great.
Yep, I have them.
Okay, thank you. Have a good one, guys. I'm signing off.
You too.
Thank
Bye-bye.
you.
Thank you.
You're
Thank
welcome.
you. Thank you, Professor.
You're welcome, everyone.